Hi everyone, I'm Eloise and welcome back to our Teacher PD microlearning series. So we're on day 5 of our microlearning sprint and today we're continuing with the 6 fundamental concepts of coding. So far we've learned about sequencing and branching, and in today's video we're going to be looking at iteration. So first of all, what is iteration? Well, at its core, iteration is a process where a set of instructions are repeated. There's a few different ways in which we can use iteration, but there are 3 main ways you often find it utilized in code. So that could be iteration where instructions are repeated a certain number of times, iteration where instructions are repeated until a certain condition is met, and iteration where instructions repeat forever. But why would we use iteration? Well, in a moment, we'll give a few examples of all the different ways we find iteration utilized. But before we even go into that, let's think about why. Well, there's undoubtedly the case that programmers are lazy. If there's a way for us to achieve the same outcome with less work and effort, oh, you better believe we're going to take it. We also, however, use iteration to make our program more efficient. If we have, say, 6 instructions that need to be repeated, it's much more efficient to throw a command at the front of it saying, "Computer, repeat this 8 times," rather than simply type out each instruction 8 times. Just as with the baking a cake analogy that we've been working with the last few days, it's much more straightforward for a recipe to tell us to repeat steps 2 to 5, 8 times, instead of actually writing out the instruction 8 times. Now, let's try and revisit the ways that you'll actually encounter iteration in code and explain them with a few examples. So first of all, let's explore how we can use iteration to repeat instructions a certain number of times. Here, we have some code that makes the character on our screen draw a square when we press the A key. So as shown in the code here, the sprite will move forward, then turn 90 degrees, then move forward, then turn 90 degrees, then move forward and turn 90 degrees, and so on and so forth. But you might notice how the code uses the 2 exact same instructions over and over in order to make the character draw the square. Well, the code could be much more straightforward if we did this instead. So in this code, we see that there are just 2 instructions inside of a repeat block. This box needs to, this box next to the repeat text indicates how many times the instructions within it should be repeated. So in this example, these instructions will be repeated 4 times before the computer will stop. So we can see how we can achieve the exact same outcome with far fewer blocks. All right, so now let's look at how we can use iteration that requires a certain condition to be met before the instructions will execute. So we'll have a look at the code just here. I'll try turning that around. There we go. Just here. So the code is exactly the same as the one before. However, instead of repeat 4 times, the code will be repeating until the spacebar has been repressed. So we'll just keep drawing that box over and over and over again until I press that spacebar. Finally, we'll have a look at some code that will repeat forever. And that will be this one just here. Now, this might actually look a bit familiar because it's the same code that we've used in part of the maze game that we've looked at a few times. So we'll try to break this code down a little bit. So we can see that we're actually combining iteration, and that's our forever loop just around the outside of it, which repeats code forever, with yesterday's concept of branching, which you can see in the in the if blocks just here and here. So the first if block controls what happens if the monkey touches the walls of our purple maze. So if he comes into contact with it, then he'll be teleported back to the start of the maze. And the second if controls what happens if the monkey touches the bananas at the end of the maze. So if he comes into contact with them, he'll say, "You win," and the sound of clapping will be played. But Eloise, what's that forever loop doing here? Well, without the forever loop, the computer will read the code like this. I'll try and explain it. Here we go. So when the game is started, so when that green flag is clicked, it will check if the monkey is touching purple walls. If he is, then it will teleport him back to the start of the maze. And if not, it'll do nothing. Then it'll check if the monkey is touching bananas. And if he is, then he'll say, "You won," and it'll play the sound of clapping. Again, if he's not, it'll do nothing. These two blocks are checked at the very beginning of the game, but once they're checked, the computer will just move on with the code and won't think about them again. What the forever block around the outside does is it ensures the computer is always checking on these conditions so that it can act if the conditions ever become true. And that's all for today's episode. So to summarize what we've learned, iteration is a process that repeats certain instructions either a certain number of times until a certain condition is completed or forever. We can use iteration to not only make our lives easier, but to actually make our code much more efficient as well. Remember, if you haven't already, don't forget to click on the link in the description to do a 1 to 2 minute mini quiz on today's topic. And if you do all 10 quizzes for each of our videos, you'll receive a certificate for 1 hour of PD. In our next episode, which will be on Monday, I'm going to be covering the last of the 6 fundamental concepts of coding. So those are arithmetic, data storage, and data inputs, data outputs. This is Eloise signing off. I'll see you next time.